On this problem, they're asking us to be able to verify the identity. Now remember that our first strategy is to be able to change everything to sine and cosine. Our second strategy is to be able to recognize our Pythagorean triples or identities. And our third strategy is to be able to recognize our difference of two squares. So whenever we have a 1 plus cosine, most likely we're going to have to multiply by the conjugate, which will be 1 minus cosine, 1 minus cosine theta. And we're going to do the same thing on the numerator to be able to make sure that we keep the fraction equivalent. Because once we simplify the denominator, that's the difference of two squares, so it'll be 1 minus cosine squared theta. And we're going to be able to substitute it with sine squared theta. So the denominator, which is a little easier to simplify, will be 1 minus cosine squared theta. And 1 minus cosine squared theta is equivalent to sine squared theta. Now remember that we're trying to achieve or get to tangent theta, which is pretty simplified. So I know that a few things are going to cancel along the way. Now when you multiply this out, you have to distribute the 1 to them both, then the negative cosine theta times them both. First, the 1 times the sine is sine theta. 1 times the tangent is positive tangent theta. Now I'm going to multiply the negative cosine times them both. Negative cosine theta times sine theta will be negative cosine theta multiplied by sine theta. And when I multiply negative cosine times tangent will be negative cosine theta multiplied by tangent theta. At this point, we want to be able to simplify this one here, and I can want to change my tangent to sine theta over cosine theta. Therefore, the cosines are going to cancel, and I will just have sine theta plus tangent theta minus cosine theta sine theta. And since that cosine cancels, I'm going to end up with negative sine theta. Remember, your tangent is no longer there. My sine theta and negative sine theta cancels out, and I'm just going to have tangent theta minus cosine theta sine theta. And the sine squared theta is going to belong to them both. And I'm just going to simplify it. I'm going to replace tangent with sine theta over cosine theta, and that's still my sine squared theta minus my sine cancels with 1, so I'm going to have cosine theta over sine theta. So let me change my division to a multiplication, and let me just do it on the side so I don't have to rewrite everything. I'm going to have sine theta over cosine theta multiplied by the reciprocal will be 1 over sine squared theta. One of the sines are going to cancel, so therefore that will give me 1 over cosine theta multiplied by sine theta minus cosine theta over sine theta. And since I have two fractions, I'm going to go ahead and add them. In order to add them, I need to have the same denominator. So therefore, I'm going to take my cosine and I'll multiply on the right. Now they both have the same denominator, so both of them will have cosine theta, sine theta. And I can add them, so it gives me 1 minus cosine squared theta And we know that 1 minus cosine squared theta is the same thing as sine squared theta over cosine theta sine theta. Remember that we're trying to get to tangent. Since sine squared is sine to both, one of the sines cancels. I'm just going to end up with sine theta over cosine theta, which is equivalent to tangent theta. And then we bring it down, and we prove, or we verify the identity. I know it's a little longer process, but if you just follow each of the steps, you should be able to verify it.